Well, hi and welcome to my shop. Thanks for joining me here. Today is March 23rd, my first day on this radio, Nordmende Turandot. I think I've done one or two of these in the past. So if you've been watching my videos as I'm posting them, you'll be aware that I've been working on another Nordmende, and I've kind of run into a bit of a problem with it. With getting the FM side of things to work properly. It so happens this radio looks like it has nearly the identical chassis inside it. So I'm hoping by working on this radio I'll gain some insights into the other one, and maybe with the two of them ultimately I could solve the problems with the other one. So what I want to do today is just assess this radio, figure out what I've got here on my bench, what its major problems might be or might not be. So I think I know the history to this radio a little bit. This radio was originally in a school, and it was on its way to the dump, basically, when it was rescued by the current owner of it. Saved from being dumped. Now, that's just terrible to think something like this might be just thrown out. So you can see right away it's got a little bit of damage here on the front. This should have a plate on it that says Nordmende. This part looks really good. It's really pretty clean actually. But down here, this is pretty dirty down here. I mean, it's been in storage, I imagine, for quite a while in the school before somebody decided to toss it. It's got a little bit of wood damage here. I'll just spin it around and see. I'm going to guess this was some tape stuck on while it was at the school with something written on it. 36. I can't read it. Maybe it was the classroom it was in. Got a speaker grill here. On the back we've got the FM antenna connection. Got this wire holding the power cord up. Let's take it off. Lots of dust sitting here, so it's been somewhere sitting for quite a while. Probably in a storeroom or something like that inside a school. That would be my guess. Let's just take a look at this cord. Just make sure it's okay. It's pretty darn long. It's a really long cord. I'm looking for just cracks or damage that may have occurred that I should be aware of before I plug this in. My understanding is at first the radio was working, and then more recently it's not working. I don't have too much more information than that. Let's just pop the back off and take a look at what's inside. Find out just how close this is to the radio that I'm currently, the other radio I'm working on, which is called a Nordmende Caruso. Put the antenna connection here. Come on, you can come out. Better grip on it. Ah, it's really stuck in there. Maybe it hasn't been out for a while. There we go. Oh my gosh, it's a dust bunny. Dust bucket, really. Oh boy, it's really dusty in there. So it looks similar but different. In the Caruso, so the Caruso has a circuit board positioned up in this area that's not in this radio. At a glance, looks pretty similar. It looks like this capacitor has been replaced here, but there's so much dust in here. Oh my gosh, it's really, really dusty. So I think it's been, I have to guess it's been in storage a long, long time. Okay, now there was a problem with tuning it. The pointer, I can see the pointer is off its string here. That's probably why the pointer wasn't moving properly. Okay, we can deal with that when... That's good though, it means the string is not broken. Broken string in these radios is challenging to repair. So there's a fuse sitting in here. So the FM tuner looks very similar. The location of the different adjustments in the tuner box looks the same as the other radio. I'm quite hopeful that this is really the same as the other radio. This capacitor appears to have been replaced, and we can't see too much more than that. Should we turn it on? I think I have to remove the dust. And let's see, the speaker is connected by this wire soldered right onto these two posts. There's no side speakers. There's no. Oh, come down here. Come down here. It would look to me like there once was a tweeter in here. The tweeter's been removed. Now there's a chance the tweeter that was there was a electrostatic speaker. My experience with those is they don't survive. And as for repairing them, I don't know. I don't think it's terribly possible. Obtaining a new one sounds like a tough thing for me. And my other experience with these radios is you don't miss it when it's not there. Okay, I think what I'll do is I'm gonna bring it out of its cabinet, get a much better look at it, look up underneath it, see what's to be seen, find out if more capacitor replacement has been done. The radio's obviously been serviced a little bit. Great, I'll get it out. So I think one of the kind of design ideas of this radio is to have the speaker wire long enough that you can pull the chassis out and maybe swing it around this way and maintain connection to the speaker. Just a convenience for a repair guy if your bench is big enough. Let's see if I can get this out of here now. I've taken out the 4 screws that are underneath it. Well, it doesn't want to move. It doesn't want to move a bit. Oh my gosh, what's sticking it to the bottom? Something gets spilled in it, maybe? Something spilled out of it? Okay, it feels like there's a ground wire. Yeah, sure enough. So these also probably have a plate underneath that you could remove. And you can access underneath without taking it out of the cabinet. But we're taking it out. Let's see what we got here. I think we need just a little more light on the topic. Okay. So the dust is really just in this back half here. It's not so dusty up in this area. You want to take a look at what has happened to the pointer right off the bat. So there's a piece of plastic here, and you wrap the string kind of around and through it. It's not done right here either. But that piece is missing over here. It's broken off. How that would happen, I have no idea. So that's going to be tricky. That'll be tricky to try to do something to restore that properly. Can't have this loose on the string. It has to stay put. I see the backing paper here. This is a piece of paper whose you have the 2 lights here, and they shine through the paper. This one has literally burned a hole. Both of them have burned holes or burn marks on the paper there. It's very typical of these radios. They suspend the paper on spring-loaded strings, spring-tensioned strings. Often one of the strings is gone. It looks like the lower one is either gone or the paper's come off it somehow. And that's probably what has allowed the paper to fall back onto the light bulbs and get burned. Okay, so this is a AM/FM radio, and it has a gearing arrangement right here. This part down in here. So when you're pushing, watch, I'll push the FM button. I think it's this one. Everything moves, and if I push any of the other AM buttons, shortwave or AM that moves back. And that is basically a transmission, shifting the knob here from turning the string you see moving now. Now push FM, and now it's going to turn the other string. You can see this is the FM tuner is moving now. So conceivably there's an FM pointer down there somewhere. You know what? There's no FM pointer in there. Well, I see it actually, but it's not moving anywhere. It's just sitting there. Well, isn't the string moving? Oh, this is kind of odd. I'm not sure what I'm seeing, but I think... yeah, I'm just not sure what I'm seeing yet. What I was going to say, it looks like the string that should be drawing the pointer back and forth is not moving. I have this on FM, yeah. FM tuner's moving. You can see how the tuning string works its way through pulleys down there to pick up the pointer and move the pointer, but the pointer is not going anywhere. What has happened to the pointers on this radio? That's pretty odd. Okay, so I'm going to take a few minutes, vacuum off the dust here, and so we can get a much better look at the components that are in there. Okay, we can get a better look at it, and I'm going to use a close-up type camera in a moment to get an even better look at it. But the kind of capacitors that I'd be concerned about finding in a radio like this, they look like these. But there's none of these in here. Now, this one looks pretty darn new. These ones could be that Nordmende, I think this is a slightly newer radio than the one I've been working on, may have stopped using these and switched to this style here. I don't see any of these guys in there, which is a very good thing. Or, not only was this replaced and this replaced, by the way, the original capacitor there would have looked something more like this than that. This is an important capacitor for making the FM detector work properly. So someone's replaced it. So at least two are replaced. These two are original, these two brown ones here. This is actually a fuse system on the output transformer here, and this piece here, it's soldered right at this point. If this thing gets hot enough, the solder will melt, and this piece will pop open like a safety pin. Pop, but it's not popped open. Okay, let's just take a peek underneath with the camera that we're using right now. Okay, so again, I'm looking for the type of capacitor I'd be concerned about. I don't see any again. There's another one of those other styles, and by the look of it, this one is a shield, I believe is a shielded capacitor. Looks like it's going down to the volume control. The other radio is a stereo if you hook up a phono to it. You know, a stereo cartridge phono. This one, I don't think it is. This one, I think it's just mono. This is evidence of it. It's just got one capacitor heading to the volume control. The other radio had a lot of trouble with cracking of the solder joints, the solder connections on the board, especially around the output tube. So we'll end up taking a good close look at that. But I don't see any evidence of the transformer overheating or anything like that. Not a lot under there to see. But pretty much all the parts are up on top, and as usual in the German style or European style, I tend to call them European style, but I guess maybe German is a better word for it. These are the rack of push buttons here, and it provides an awful lot of terminals. And I like to build these radios on those terminals, and that's why all these parts are sitting up in here. And these are all the adjustments for the shortwave band, long wave band, and the broadcast band and the FM band. Most of the FM RF adjustments are up here. In fact, all of them are up here, really. So it looks pretty similar. The output tube is different. An ECLL 800. Never heard of that tube. Now let's take a look at the back. What did I do with the back of this radio? Here it is. Because on the back is a diagram of the tubes. ECC 85, ECH 81, EF 89, EABC 80, ECLL 800. And then this is an EM 84, but this is ripped here. It's an EM 84. This is all in German. It's all in German. Okay, well, it's got its tubes. Looks like the right kind of tubes. I think that part of my way of doing these things is to try to get whatever I'm working on operating to any degree as soon as possible. As soon as I think there's little risk to trying to start something up, I like to start it up. I think that's what this one qualifies as. Look at this capacitor. Let's get the close-up camera going here. Switch it here. Okay, untangle the cord. It's all tangled up in my shop. Okay, we'll start over here. So we're just looking to see what's up. Lots of dust and dirt down in there. Those are all the adjustments for adjusting FM radio. What's that sticker say? Oscillator, I think. Oscillator neutralization. Nicht verstehen. I think that means don't touch. I think that's what that means. Don't touch. I don't remember a sticker saying that on the other radio. There is an adjustment in here. Same on the other radio. Right down in there. You can see the screw head. Well, I could not move that in the other radio, and I didn't want to force it too much. Didn't even really want to turn it too much, but this one may be in the same boat. Generally speaking, you don't need to adjust these. That's my experience. They are usually okay as they are. But I haven't got an awful lot of experience with these. Okay, so we'll just look along here for anything that might be out of sorts, but there's just too much to look at. Still got lots of dust in there. You can imagine there's dust inside the switches. The other radio and others I've done like this have a lot of trouble with the switches working properly. That includes the on-off switch, which is surprisingly, there's dust way down deep. I guess I didn't stick my little dust broom that far down. The on-off switch, surprisingly, sometimes is a pretty ordinary toggle switch connected via a chain or a string or a wire to the push button. Not this one, though. It's like the on-off switch is just incorporated in the main bank of push button switches. Okay, I'll just carry along the back side of a board here, looking for resistors that are burned open or any sign of heating or anything leaking out of anything. Any signs calling for help. See, somebody's piled up some stones. SOS, anything like that. So here's the replaced capacitor. There's no question that's been replaced. That is a fuse link there. That's what I think that is. 0.2. That's probably its dimensions, like 0.2 millimeters. Yikes! Don't break that. I don't know what to think of that. Maybe it'll appear on the schematic. Now here comes something that's a little interesting. There's a capacitor that's cracked right open. That orange one there. It's just split right open. Of course, where is it? Well, it's tucked up pretty tight to this tube. This is not a particularly hot tube, but that's a hot place to be. It's cracked all down the front. Oh, I've never seen one crack like that. I wonder if it exploded. Sometimes these things will pop. Oh my gosh, this scared the heck out of me. That's my cat, Peanut. Yes, sir. Hey, what are you in here for? Yeah. He's ready for some cozy time with me, but I want to finish this. Can you hang on a little while there, Peanut? I guess that's a yes. So, hard to tell for sure that these are original, but I think they are. I think everything is original in here except those two capacitors. And these look like they're probably high quality capacitors. Kazunite. He's been sneezing a lot. Oh my gosh, there's another cracked capacitor there. It's cracked and then it's full of dirt. So I don't think I can turn this radio on. It looks like it's packed with dirt. Maybe not. That's interesting. Here's another one of these capacitors up here. This guy's okay though, I think. Huh. Oh, hang on, Peanut. I'm almost done here. He spent lots of time with me today. Still tons of dust in there. Yeah, I don't think I want to turn this guy on until I've dealt with those cracked capacitors. Not that I think anything terrible is going to happen. I just think it's not going to work well. What's the use? You see something like that. Here's a closer look at this broken piece here. So you can see on this end it's got two pieces. Yes, hang on, Peanut, come on. His patience is wearing thin. After all, he's saying, who's in charge here? He's in charge. See the burn on the piece of paper? I think this would cause a pretty smoky smell. Yeah, it burned right through, I think. Peanut, just hang on. You know how this works. Now, a little hard to can't see it in focus down there, but that's the other pointer. It just sits there. I'm going to tune the radio. Okay, that pointer should be moving. Can you see this? Is the string moving through there? I don't think the string is moving. Is it on the wrong string? Hang on 1 second here. Peanut. Peanut, my cat. Yes, he's stars in lots of my videos. He's at the door looking at. I'm going this way. I want you to go this way. Peanut. Peanut. Don't just listen at me, look at me. What is it you want? Be specific. Oh boy, now, okay, he's getting angry at me. I don't want an angry cat. Okay, I'm going to stop for a bit. You've seen a fair bit already. Okay, I got the radio up on its end. Let's take a look and see if we can figure out what's going on with that lower FM pointer here. I think I can see it already myself. It's broken also, in the same way. So I'm going to take a wild guess here that somebody poked around with it and broke it. Or maybe, because there's tension on that string, maybe it just broke on its own. So they're both broken the same way, and that's why this one must not be moving. Let me move the tuning dial, and we'll just see if the string that it's sitting on is traveling. Which string is it? Yeah, you can see the string moving there. Okay, It's not even sitting on it, is it? Well, you know, it can be fixed by gluing the string to the pointer. That might be where I end up going with this. It's pretty hard to try to restore the original plastic shape. See, that looks fractured and broken right there. Just the piece hasn't fallen right off. Maybe that's what happened. It was just from its own tension over the years, it just gave up the ghost. So yeah, so of course this means these pointers are not in the right place on these strings, even if they did move. They may not be. While I got this up on its end, now we take a close look at a few things. First of all, this is the output tube socket right here. Let's see if we can see any cracking on the solder joints. Now the reason they crack on the output tube is the output tube is really hot. So there's one here. It's catching my eye. This one right here. They don't look perfect. The two of them there don't look all that good. They heat up. The tube heats up. There's another one that looks like it might be cracked. That's this one right here. Cracked or kind of turns into a cold solder joint. Heat comes down the pins, heats up the solder. The solder is not a very stable material. So you heat it up a bit and it'll go through metallurgic changes. It's an alloy. It looks like a cracked. It's either a crack in the trace right above my finger or it's just two flows of solder where they met. It looks like a crack to me. Now there's nowhere else in the radio that really gets hot. Like these other tubes, they don't get anywhere near as hot as an output tube. A rectifier in here is not a tube. It's going to be a Selenium Rectifier, which we'll take a look at. I think a lot of repair guys would replace the Selenium Rectifier without much thought. I tend to, as usual, overthink things. It's got, same with the other radio, it's got this in it, whatever this is. Funny trace on there. Pretty good. I think I have to just run for a couple minutes here. Okay, I'm right up at this point. The big hole. I'm at the big hole. So I know where to pick up from in a moment. Okay, interruption over. Back to the big hole here. Here's the on-off switch. Just like I said, it's a toggle. It's a toggle switch. Let me turn the set on and off here. That's on. That's off. So it has like a claw. Okay, so this is off now and on. Well, it moves. Presumably it works. Yeah, I don't expect to find much under here. Have to remove one of these capacitors anyway just to test it, just to see what condition it's in, then I can judge whether they all need replacement. Okay, here's some of these slide switches are just totally exposed here. Considering the amount of dust flying around, I mean, there's a chance these are a little they look okay. Probably okay. And variable controls. For some reason, German radios just they go nuts over tone control. This is the power transformer. Was it ever overheated? Does not look like it. There's the fuse. Now the rectifier is this aluminum piece here. Leads coming out the left end. So these I think are quite reliable, and I also think they go through a slow death spiral where they get hot and hotter and hotter until finally they're just too hot. So we can check this by feeling for excessive heat in it. Okay, very good. I'm going to attend to those, at least 2 of those cracked capacitors, and then we might turn it on. I'm going to have to think hard about these pointers. I mean, they're not particularly accessible. You really have to take the front glass right off to get at them, and the glass is held in. Screw here, I loosen that off, and this bracket part will slide up and release the glass. The glass is mounted with this will probably foam or some kind of spongy material, rubbery material. You don't really want metal clamping on glass. And you know what? Is this even glass? I don't think this is even glass. I think it's actually plastic. Pretty sure actually it's plastic. So maybe that's not quite a concern. Okay, a couple capacitors, gotta go. Okay, looks like this one's pretty easy to get out. I can just get a grip on it. Hopefully it doesn't get too hot. I think I know which terminals it is. It's right here. Out. It's coming apart, that's what's happening. Get a better grip on it here. Yeah. This one. Maybe I was pulling on the wrong, maybe I was desoldering the wrong ones. Not be it. here. Yeah, I was pulling on the wrong thing all this time. Well, here's what's left of it. I get to see inside of a capacitor. Yeah, it's wrecked. Alright. And what size is it? Goodness knows what size that is. Shoot, I'm going to have to get the... Yeah, let's look at that under the close-up camera, just for some fun. Lots of fun. You can see how the lead comes in. It's just soldered to the capacitor plate there. And the other lead I broke right off, so it's gone, but you can see where it was. Attached there. Looks like some corrosion's taking place in there. And then the white material around the outer edge is probably the dielectric. That goes between the two plates. Okay. Well, I'm going to have to stop and sort out what size capacitor that is. I don't want to really guess at it. As usual, simple things are not simple. So, oh, wrong camera. There. You can see the two holes I removed the capacitor. There's the number. C136. Or is that this big one here? No, I think the big one is denoted by C141. C136 should be a simple matter of looking it up on the parts list. But it's not, because I'm looking at a schematic that's not from Nordmende. It's an English written schematic developed after this radio went on the market. And it uses a different numbering system for the capacitors. Also, it has a pointer. Maybe I'll show you this. It has a pointer, I'm pretty sure, pointing to this one. But it appears to have no pointer pointing at this one. So I can't identify their number for this capacitor. Why wouldn't they use the same numbers? Maybe it's some kind of copyright thing or something. You can see how the board is darkened down around the output tube here, which gets very hot. Which is why you can expect solder crack problems underneath it. So, okay, I can't figure out the size of this one easily. Maybe I can just cheat by looking at the other one. So here's the other one. Get it here so it's in focus. There's nothing written on this side. It's very awkward, but on the other side, let me put some light on that. Who's got my flashlight here? Oh, there might be something written on there. Break it into pieces here. I think they're the same size. I don't know. And then this one, this is also a very similar looking capacitor. Nothing written there. And on the other side, I think there is something written there. Yeah, maybe if I get a look at that, that'll give me a size. Let me try a different camera I can get a little closer with. Okay, we'll take this camera and see if we can get a better look at the... There it is. So what does that say? What do you make that out to be? 0.1 nano. 0.1 nano? It's possible. That would be like 100 picofarads. Is that really what that says? What about this other one? Maybe we can see more with this camera here. Pretty sure when I get this out, it's going to be in pieces. Huh. And for sure there's nothing on this side. Oh boy. And what about this little piece here? No. Where's the rest of it? So the rest of this capacitor slipped from my fingers and disappeared underneath the radio, just up in here somewhere. And would you believe it? I can't find it. It couldn't have gone far. So I'm going to look for it, because I need a hint. Because what I'm going to show you now is what you can see on the schematic. It's not actually a schematic, it's a diagram showing the component locations. So the one I'm looking at is right in here. And so there's this larger capacitor that's in the radio. And here's the numbering thing. It's C58, but the number in the radio is C141. And when you look at the related parts list in this, who did this again? This was done by, where's their, I thought they put their label everywhere. Here we are. It's a SAMS. And using their own numbers. Did they miss this capacitor? Is there more than one version of this radio? Could be a couple of different chassis versions. Well, what about the other two capacitors? Where are they located on here? So one of them is right in here. There's no arrow pointing to, well, maybe this. Maybe this arrow. C43. Now, it looks like there's something on this angle here. Let me look in the radio and see. No, there's nothing there at all. There's nothing there at all. So maybe this is it. Maybe this will be the hint. Follow this, C43, and look for the parts. The parts list. It's in one of these. Here we are, right here. C43, 30. Rating. 30 picofarads. I think it would have to be. They must say some capacity values given. The rating column are, for paper, and in picofarads for mica and ceramic. So this would be 30 picofarads. We didn't see anything like that on that other capacitor. Hey, let's go after that other capacitor. They all look to be the same. Now the other capacitors right at the front here, right in, I would say there's a resistor and a capacitor right in front of this tube. So what's this pointing at? C41. Yeah, it just doesn't look like it's quite right. C41. C41. 4700. That's a lot different than 30. 4700. It'd be like a 4 point. Well, it'd be 4700 or 4.7 nanofarads. Let's look at it again. 4.7. Well, that is 4.7. 4.7 nanofarads. Okay, let's look back in the parts list. How many 4.7 nanofarad ceramic capacitors are there? 1, 2, 3. Looking up the list here, that's it. So, aha. That kind of matches. Is that the end of the capacitors? 45? No, there's more. Oh, another one. Oh, many more. Well, Well, they like the 4700s. We have one that clearly is a 4700. So 4700. So these numbers, they might be close to each other physically. If the number's close, they might be physically close. 4700. Let's go back to the diagram here. What am I missing? There's a C2 here. No, it's over on this side though. Oh, that looks, well, I don't know what that is. This, I think, well, they show it as a resistor. There's a coil right in here too. Small coil. V6, that's the tube. Well, let's see if some other stuff matches or doesn't match. Like if you look along here, you've got a capacitor, a resistor, something, and then another what looks like a capacitor. So I'm going to take a peek in the radio right at that spot. That's between the two cans, and I don't see much. It's dark. I see, no, they're not, they don't look like that. This is not looking right. I think I'm looking at an incorrect schematic here. But I did manage to find the size of the one capacitor. Now let's just see if they all look the same in terms of their size, their physical size, which isn't exactly helping, but okay, so there's that one. Get a load how big it is. And there's this one. Certainly looks the same. And there's what's left of that one. I can hold this one up here. They really do look the same. $4,700. I think that's what I'm going to have to run with. 4,700. Okay, well, better to have something in there than nothing. I've only got one out so far. Great, 4,700. Okay, I've got 4.7 nanofarad. This type of capacitor, though, I think this is a, I'm not sure, tantalum film capacitor, I think. High voltage, it should work. I don't know what the voltage is supposed to be. I don't know if the schematic I have, aside from what I was showing you, the schematic itself could be incorrect. Okay, so we got that one in place. Wait a minute. Yeah. Sometimes these radios have holes through the circuit board that nothing goes in. So sometimes they'll cluster 2 or 3 of these together. So one of them is the hole you're aiming for, and the other 2 are just holes for who knows what reason. Maybe they use the same board for different circuits. I think I got a better lighting for my shop here. Actually, I have a better light. There we go. Okay, that's one in place. Now the other one. I'm just going to carry on my own and get the other 2 out of there. Okay, there it is. Let's take a close look at that. Maybe we can read read something on it. Nothing at all there. Oh yeah. Oh. Okay, I think it says the same thing. Just the 4 is messed up. Really messed up. Yeah, I'm gonna run with 4. Yeah, I think that's my best choice. 4.7. Okay, put that one in. Okay, solder up those 2 guys. Where did the other one go? Just broke one of my general rules, which is when you're not using the soldering iron directly, put it away. Put it in its holder. Don't hold it off to the side while you do something else. But I got away with it. Excellent. Okay, so that's 2. Then the one on the back actually looks okay. Leave that one in place. Maybe these ones cracked because they're in a hot location. Loose screw here. Oh, that's where the ground wire went. Yeah. There we go. I think it's ready to be operated. I'll just save this guy. So in my mind, capacitors are pretty much a structural thing. It's the the position of stuff that gives them their capacitance. So because this one's not cracked or distorted, there's no reason to think it isn't the correct capacitance. Facing the wrong way here. Oh yeah, the pointer. Well, we won't worry about the pointer because the strings are moving. One thing we should worry about is putting these tubes back in. Can you see inside that tube? There's actually 3 tubes in one. 3 tubes in one. Towards the end of tube design, the tubes got quite fat, got more pins on the bottom. They're called compactrons, and in them can be a lot of stuff under one tube. And they were used in televisions. I don't know if they were ever used in radios. Okay, off you go. Yeah, any reason why I wouldn't start this up now? Well, probably could think of a couple, but I have ways of applying power progressively. So we start with restrictions on the power that's being fed and ways to recognize when things are going okay and when things are not. It's very simple. I rely on dim bulb system. dim bulb arrangement. Maybe that's a better word for it. System's too big a word. Dim bulb arrangement. Non-polarized plug. I also have an isolation transformer that this is powered from. My dim bulbs. Just one sec here. Turn off my soldering iron. The dim bulbs are located here, and I'm going to there are two of them, and I'm going to undo one. So all the power that reaches the radio will be forced through this light bulb on the way. So if there's a short circuit in here, this light bulb is going to come on bright and stay bright. It's going to come on fully, in fact, if there's a real bad short circuit. Now it's a little tough. This radio is kind of big. That light's going to come on pretty bright. So it might be a little tough at first to tell if there's a short. But let me plug in the FM antenna too. But even if there is a short, the amount of power being delivered to it will be restricted. It'll give me time to decide what to do. You know, basically run out of the room, run for the hills. Okay, we're in my little switch panel here. You have two switches, one here and one here. Now I'm going to turn off the overhead light. That way the smoke and flames are much more exciting to see that way. Put a brake on here so it won't turn. Okay, I think we're set. We'll just go to broadcast and see what we get from that. But the main thing is, what does this light do? Which you can't see now. There we are. What does the light do? That's the question. Okay, this is off, so we're going to check to make sure. Off is off. Okay, we're going to put it on broadcast. And we're going to flip the switch. And that's bright. It looks different in my eyes. Like it's dimming, so that's good. Dimming is good. Dimming means the power supply capacitor is charging up. We're going to give it a little while. This is probably too little voltage to run this radio. 65 volts right now. Looks like the panel lights are burned out. The volume was up full. Lucky I caught that. Okay, we're still at 67 volts. That's too little. So I'm going to screw this light bulb in. I'll probably raise it up to around, I can see this magic eyes come on. Excellent. 104, that's plenty. Come on, radio. Not a sound. Why no sound at all? It's connected. You see the output tube is warmed up. Detector tube is warmed up. FM tube is warmed up. This mixer tube is warmed. They're all, and the amplifier, the IF amplifier, they're all warmed up. They're all warmed up, no place to go. Let's try this again. There's not a sound. Not a sound. Total silence. Well, that's not a good sign. We'll just flip it over here to shortwave. Expect exactly the same thing. They don't have an antenna on it. Well, that's the thing. Broadcast did have an antenna on it. Some of these radios with no antenna, they make absolutely no sound. We'll try the FM side of things. Okay. So we're going to watch the magic eye and see if it does anything at all. Nothing happening. It's partly closed, I'd say. It's not wide open. Let's go back to broadcast and watch the eye to change. It did change a bit. Tune around. Dragging this pointer here. Oh, it's on. So the pointer has a bottom string to support it. Just leave it dragging like that. Hey, there it goes. It's working. The bottom string's just a guide string. It doesn't pull it at all. So there's no action here. No action. we're on broadcast, so we would expect something. Well, I think that's for the next video. I think we'll be doing tube testing next. The total silence suggests the output tube's not operating. We're at 99 volts. That should be easily enough to make it operate. But the output tube may not be operating. And with this not changing, something's going on further up in the radio. Could be the just bumped the cord here. Could be the IF tube here. So if we do a little socket wiggle test, turn the volume up. Get ready. Yeah. Okay, so that tells us the audio circuits are working. Nothing coming from here. Expect some kind of crackling or staticky sound, but way up in volume. Get ready to jump. Nothing, just in case. Let's go back here. Oh. A little bit of noise. This is still not operating. Well, she's got a problem. It's got a problem. Could put a signal into the, it could be any of these buttons up here. Not likely, but let's fool with them. They're just tone buttons. And it wouldn't account for this not operating. Presence, brilliance, these are just tone controls. So, they might affect the audio, but this guy should be moving. Especially on broadcast, could be dirty buttons. Don't hear anything. Nothing. Now there's no FM antenna, so this isn't a very fair test, but I think most of these radios would, even without an antenna on them, there's enough stuff here to pick up something. I don't hear the hiss either. Okay, that's good for now. We've proven it doesn't work. So tubes are next, and we'll go from there. So thanks a lot for watching. See you on the next video.